Okay, we're going to get started with the next talk. Please welcome Paul Querna from ScaleFT.
Okay. I have a couple questions. How many of you would consider yourselves more developer than operations? Okay. And how many of you consider yourselves more operations than developer? And then there's some people who are neither, so that's great. Okay, so I'm the CTO of ScaleFT. My background is kind of jumping between developer and operations for my whole career, regardless of like what that means, right? Like DevOps or whatever. So I want to talk a little bit for a second about like what ScaleFT is and why compliance is relevant to us. We are basically a SaaS, or we have an on-appliance thing too, but we are an authentication service for our customers. So our customers use us to log into their production environment. And that means we have to be really secure. So what that really means is our customers send us 200-page questionnaires about everything we do in production, and we run CoreOS. So that means we have to answer those 200-page questionnaires and include a lot of commentary about how awesome CoreOS is, but also do a lot of work on CoreOS to make it more compliant, okay? So CoreOS plus compliance, right? So compliance is a terrible word, and I'm glad any of you decided to come to this talk because it has such a terrible word in the headline. When I think about compliance, I always think it's old and terrible, and CoreOS is fun and new. What I really think about compliance is we're really about risk. It's really about risk control, risk mitigation, understanding your risk, and that's how many compliance standards are structured, right? They're trying to prevent the risk of a data breach or prevent the risk of an unauthorized access, right? So look, there are hundreds of compliance standards. I was like going to make a sweet slide with all these like, you know, vectorized logos, and I started looking around and I was like, oh look, Microsoft has a web page where exactly they do this. They have like hundreds of logos of different compliance standards. There's so many, okay? They come from governments, they come from private organizations, your company might make up their own compliance standards, but really they're just a collection of rules most of the time, and a lot of them have common themes, okay? And so what I'm going to talk about today is a little bit, I would say, I'm going to take things from PCI. This is not an education course about PCI. Good luck if you need to actually pass PCI based on this talk. But like, I'm just going to use them as an example because they have a lot of good basic sections that apply to CoreOS pretty well. But if you're trying to pass a specific compliance thing, it's going to be a lot of work. But a lot of them have very common basic elements. Okay, so that's what I'm going to work through is those common basic elements. Almost all of these compliance standards have kind of different parts. PCI kind of has policies and documentation and interviews of the team, and then they have a bunch of technical requirements. I'm going to, again, mostly focus on the technical requirements. Again, when I say controls, I really mean things generally to reduce or manage risk. The risk that someone has a static password, you want to reduce that or eliminate it completely, right? Okay, so the first fun topic, user management on CoreOS. Who here has logged in as the core user on CoreOS? Probably everyone, right? And then you're like, well, okay, I want to give my friend access to the core user or a coworker, and you know, you could just put an SSH key in there. Then everyone's on the core user. You know, this is interesting philosophy, but it doesn't really work with most compliance regimens, right? Like, pretty much the first thing a compliance and PCI says is you need unique user IDs for everyone accessing a system. So really what they say, most of them say, is something like you need unique user IDs, you need role-based permissions where, you know, the senior sysadmin has sudo and can do stuff, but the developer can only view logs or, you know, like those kind of roles and permissions. And you also need kind of lifecycle management, right? So when someone leaves the company, you need to make sure their access is actually revoked, okay? And if you're doing this on a traditional, like Linux or RHEL or Debian, you know, you see a lot of deployments of either LDAP or maybe Kerberos or different things that hook into the OS that way. But on CoreOS, that's not really possible, right? Because there's no PM integration. Today, there's no LDAP integration. But they might add it someday. But today, that's pretty tough. So I'm going to go through kind of our war stories of where we started. So our first strategy was to let's just put it all in Cloud Config and Cloud Init, right? And if you're booting servers on Amazon, this is actually pretty convenient. You just put more user data in and keep adding users and adding SSH keys and maybe put some unit files in there too, and it feels pretty good. You make some mistakes with your YAML and the server doesn't boot, so you just throw it away and try it again. This, has a mixed experience as you move beyond like just booting cloud servers. You can still use Cloud Config, but then you're waiting 20 minutes for a box to reboot in Pixie and initialize all SCSI. So it's like, it's not as fun as the kind of the iteration speed you might get on a cloud environment. It also, turns out, had a lot of pain. So, right, here's your Cloud Config. It's easy. I have my user. It's an array in YAML. We all love YAML. It's totally precise what you mean. And so you just add more users, right? Like, add Joe, add Ed, add Brandon. Just add them to my users array, and everything is awesome. Oh, and I give them sudo, so this is my role-based thing where like I can dynamically decide if someone wants sudo or not. Yeah, I mean, there's a static SSH key, and I don't ask for their password because setting the password was weird and didn't really work right. So, okay, I have a bunch of users. It actually was completely terrible, and we did this for a while, and it was not fun. So if you were at CoreOS Fest last year, Alex Crawford, one of the CoreOS OS team developers, he gave a talk about his new project called Ignition. And I was searching that talk for like a quote about how much he dislikes Cloud Init. And really all he said is, there are a number of hurdles. And then he spent 20 minutes of his talk describing about like all 40 things that go wrong with Cloud Init. So hurdles is putting it lightly. It has a lot of problems, okay? And so I would encourage you not to base your like compliance strategy on doing things in Cloud Init. So just some examples. We started writing a lot of Go. I mean, we love Go, everyone loves Go, but we were writing a lot of Go just to generate YAML to then dump into Cloud Init, okay? We were getting all their people's public keys from Git. We were like inline script rendering, base64 encoding stuff, dumping it in there. We were putting in system to unit files. And that was all kind of fun. I mean, you end up with a couple kilobyte Cloud Init file. There's some limits on certain cloud providers to like 4K, so you don't want to go over that. But it's we ended up putting a lot of engineering work into just making a YAML file, and that seemed kind of weird. And then there's kind of the fun part of where like, if you reboot a box, it just reruns the Cloud Init. Like that's the behavior, it's documented as the behavior. We didn't really think about that through the first time this happened. We had to remove a user. We deleted a user on the box post-build. The box later upgraded because CoreOS auto-updated and rebooted. And then they're back with their SSH keys. And so that was not ideal. And we're like, well, what do we do about that? Like you can't, it's just the nature of Cloud Init is like, it runs everything every time. So that was, I would consider, kind of a very painful hurdle for us to figure out. We thought it was kind of a more, and on Ubuntu, Cloud Init and Cloud Config behaves actually a little bit differently. If you later delete a user, they only do that user creation on the first boot, but CoreOS does it on every boot. So it created some panicked moments. The other thing is what I think we really kind of realized is the life cycle of our configuration, we had a major mismatch with the life cycle of our servers, right? Like, our config was actually changing very often, right? Like, it was changing not daily, not necessarily daily, but we were deploying new software, adding, removing people on our team, changing their SSH keys, changing group permissions and roles. That rate of change did not match how long our servers were living. Our servers were living longer for various reasons. Now, you could say there is an approach to this where you're like, well, every time you change something in your config, you burn down 100% of your servers and rebuild them. And you can do that, and people do that. It's nice if you don't have data on those servers. Like if you only use RDS or hosted data services, that is probably a more viable pattern. But we had actual data on our servers, and so it was very painful for us to do an 100% burn down just because we added a new team member or removed a new team member. So we started looking for a better way of doing this. And so our round two of attacking kind of user management is, I call it kind of light cloud config, right? We still use cloud init, but we try to do as little as possible in it, okay? And all we really want to do is to bootstrap the ability to run Ansible. So then we can do more stuff, right? And you could say the same thing whether it's Ansible or Chef. Well, Chef doesn't really run on CoreOS, but any other way you want to manage the box later, I just want the cloud init to really just be an init system of getting my OS up so that I can get in there the first time and get started. So this is actually almost the entirety of our current Bootstrap cloud config. We have one script file, and we have a one-shot unit that runs it on the first boot. And that basically covers, and there are our shell script, which I just omitted here. All it really does is download a tarball, and that's basically it. Like downloads a tarball and extracts it to opt, which I'll get to in a second. And so that keeps it really simple. Like this doesn't have a need to change almost ever. So it prevents a lot of the kind of, oh, we have to burn down our entire infrastructure because we changed something. We also put in run guards in the script so that if it's run twice, it just exits 0, no op. So when it reboots after an upgrade, we don't run the script again. So we're just trying to really, really minimize what goes in our cloud config. And so that brings me to getting Ansible to work on CoreOS. Ansible, kind of touts itself as like, oh, we don't have agents. It's very lightweight. We do everything over SSH. And that is marginally true. They do everything over SSH. What they don't really put on their homepage is basically they invoke SSH and then like ship a Python module to the remote machine and then exec the local Python. And if you're probably aware, CoreOS does not have a local Python by default. Some of the OEM versions do for like Azure and stuff, but like the default distribution of CoreOS does not have Python anywhere. And so we actually tried like, well, maybe we'll put Python in a Docker container, or we'll like build a custom build of like CPython from scratch, and like wasted 2 days with like linkers and dependencies, because like CPython depends on SQLite and TCL and all this other stuff, and you're like, holy crap. Like I just want to have Python that Ansible will work with. And so luckily we actually found this thing called Portable PyPy. And there's this guy that has this whole project, and he basically takes the latest PyPy release, which nowadays basically can run all Python, and builds a statically linked, or almost completely statically linked build of it. And it's really nice. You just have a tarball, you extract it to opt, and we add a symlink. And now we have Python. And then the only trick is you just have to tell Ansible where to find Python, because we don't put it at user bin Python, because usually that's, well, potentially read-only, I guess. And it basically works. Like we were kind of amazed. We were like, oh, like the users module works out of the box. File module works out of the box. There's definitely some complexities, right? Like a lot of the Ansible tutorials, you get into like, adding Debian packages really quickly, like add all these packages. None of that stuff exists on CoreOS. So you're going to be writing a lot of your own modules to do things, but you still have all the basics, moving files around and controlling, starting processes and running shell commands. So it's enough to get you rolling. And I would say our future goal here would be to figure out how to do this with Rocket Fly by packaging up the Python in a Rocket container and just making it a little cleaner than us like wgetting a file and untarring it to /opt, which just doesn't feel very 2016, but I think we're getting close on that. Okay, so in most compliance things, as they get bigger, they tend to ask for potentially, I would consider, silly things these days. They're like, well, you basically need to run antivirus on all your servers. Does that make sense? It's CoreOS? Nope, it doesn't make sense. But it's the rules. You got to live by the rules. And so usually those things become our agents of some kind. They're software you have to run on that machine. They might be backups. They might be for antivirus. They might be for user management. There's a bunch of things they could be. But you'll need some kind of agent on these servers. And so our first strategy was like, okay, let's just put them in Docker. We'll bind mount things that seem relevant. So we'll put that antivirus agent in there, and we'll bind mount some directories, and then just call it a day. Yes, the antivirus agent runs on this machine, but does it do anything? No one's sure, but sure. So we just said, okay, we're gonna put them in Docker. The Docker stuff was not very fun, okay? Because a lot of these agents kind of expect to be, well, first of all, they expect to be on a RHEL 6 box. So, you need to start with CentOS base. But they kind of just expect to own the machine, unfortunately, right? They want to see processes. They want to see different parts of the file system. And so it's just a kind of a mismatch, right? That you don't want to, I mean, you can run your antivirus in Docker, but it really has no purpose then, right? And so what we ended up doing is we were just mounting basically every part of the file system into the Docker container, and it just felt kind of weird. Like we had this 300, 400 meg Docker image that just mounts everything. And so it's kind of a wacky situation. The other thing we kind of ran into, especially a year ago, was like the kind of systemd integration with Docker was not awesome. And it's just like how you put in the Docker run and the exec pre-start and exec post and trying to clean it up, and like it just wasn't a very fun experience. Although we eventually made our like 40-line unit file that seemed to mostly work with Docker, but every 6 months someone does a new blog post about there's a new way to do it and maybe it'll get better. But it was just not, it didn't feel good. Okay, so we pretty quickly said, okay, this whole container thing is an awesome movement, but what we're trying to do here is actually fundamentally a mismatch for containers. We're not trying to containerize our different agents. We actually want them to run on CoreOS. So our kind of round 2 attempt at this was we just untarred we made tarballs, extracted them to opt, and then we had Ansible create systemd unit files. And this was great for things that are actually self-contained, right? That are nearly statically linked or are ready to go. But that is also not the reality of this world. You have like agents written in Ruby and stuff, and it's just a slow path to like bundling every other language into your CoreOS machine. So I don't think this was awesome. I mean, it worked. We got our agents deployed, but now we're shipping Ruby and Python onto CoreOS, and it's kind of missing the point, I think. So what we started doing actually just very recently. So we tried using Rocket a year ago when we were first deploying a bunch of these agents. It was pretty young project, if any of you guys have tried it back then. It got a lot better. I mean, this is the honest truth. Like, we tried it again 60 days ago with a Rocket Fly stage 1, and we started porting over our agents. And it's great. Basically, we can put in a slash agent name file system where we put all the dependencies and everything we need, and then we run it with Rocket Fly, and it has everything in the base OS. We still have to do some messy stuff with bind mounting all the right places, but it sees the PID name, it's not in a hidden PID namespace, it sees all the processes. So it's generally working a lot better, and I would say this is kind of in progress for us. So I don't know if you guys have used ACI Build, or AC Build. It's how you make an ACI for the most part. And it's actually pretty easy. Like, it's basically, we have to think about it is, every time you run AC Build, like begin, it creates a new directory, and then until you run AC Build right, it's just kind of messing with that directory structure and doing things to it and adding files or setting permissions or different things like that. Or setting metadata. So the one funny thing about AC Build is, because you're just messing with a file system underneath, you need to set permissions on it like it's going to end up being like the Linux container. So, you see this inline chmod chown there. And which kind of sucks about this is you basically have to run as root to do AC Build. So this was kind of annoying. We have all our build machines running with the deprivileged users, and then we have we want to build ACIs. Now we have to give some way to run sudo for this one script. But you can kind of work around it if you're really good with tar, but it's just a lot of pain if you're just trying to get something done. So it's pretty easy, but it's still a little rough, I would say, if you're trying to use Rocket and AC Build. Okay, and so once we had these agents that actually worked, we decided to dog food it. So our product actually lets you manage Linux users. And on Ubuntu and Red Hat and Debian and stuff, that's all pretty easy. But on CoreOS, it's a little different. So we wanted to dog food our own agent in our own production. And it's pretty easy now. It runs with Rocket Fly. And if you look at the docs on our website, it's basically 3 commands, like Rocket Trust to trust our signing key, and then just the unit file, and you're basically done. So it makes these agents, building them much easier. Okay, so any part or almost any compliance thing has some kind of logging requirements, right? Either what you log, how you log it, where it goes, who can see it. I would say this is probably our part we've iterated the least on, and I'm least proud to talk about. Okay, the log controls. Most of them are pretty simple. They actually you need who did it, what were they doing, when was it done, prevent someone from deleting them, and then ship to a central location. And that's a pretty common pattern in most compliance requirements, right? You want to get it off the source machine. You want to who did it so that you can actually correlate things, which is why you have user management. And in traditional Linuxes, you would say, well, between syslog and a few other things, and auditd maybe, you can get pretty close to being done here. But again, on CoreOS, because it's fully in systemd world, there is not some of that same plumbing. Okay, so yeah, systemd journalD is actually great though. It actually has a lot of these nice properties, right? It has a feature where it will kind of do a rolling signature of the log entries. So if someone tampers with a log entry, you know that they tampered with it, right? So it has a bunch of features that are actually very positive from a compliance point of view. But it's mostly that there's just not a lot of operational tooling around it yet, right? The big distros are just now starting to ship systemd. So there's not a lot of tooling, right? Everything takes in syslog as an input. Not everything takes in kind of systemd journal stuff. But I would say this is probably the thing that's changing fastest. So you want to look at new GitHub projects because it's changing pretty quickly. So our first strategy, which I think sucks to say is still kind of what we're using in production right now, is we basically just dump them to JSON and ship them up to S3 all the time. And while I think is functional and it's easy, it's in JSON, we can dump that into Elasticsearch pretty quickly. It's not awesome. And I don't really want to share my shell script. That's how awesome it is. But where we're going and kind of in progress of doing is what I call, well, there's this project actually on GitHub called JournalBe. And it has native integration with the systemd journal, right? So it uses the actual C APIs to follow the journal, keep a track on the cursor where it is. It does it all right, and then it ships it up to Elasticsearch. And so what we're working on right now, we posted up on GitHub, is actually a ACI build of that, so that you can run that in a container. And that build of that is it's like 5 megabytes. It's a pretty awesome little container. And it just plugs right in to the existing systemd journal. Okay, so now the reason CoreOS is awesome, the reason and how it is making the internet more secure, right, is that it auto-updates all the time, right? That's awesome, and Chrome does it, and everyone likes Chrome, and CoreOS does it, and everyone likes that, and it's one of the kind of interesting first features that CoreOS pushed on. In the compliance world, things like auto-updates is a really confusing topic. So it's actually great. So in the PCI standard, they're like, if you have antivirus, you must turn on auto-updates, okay? Everything else, they're like, well, we're not really sure what auto-updates mean outside the context of antiviruses, right? So I think it's partially a case of the technology is running far ahead, in this case, of the standards, right? I can't believe anyone would say, it would be great if you never update your base operating system, right? Now, most of the compliance standards do say, hey, when a vendor has an update available, you must deploy it within 30 days or 60 days or 45 days, depending on the standard. So they do say they want you to update stuff, and they want you to do it quickly, so if you have a Red Hat box, that means you do yum upgrade or apt-get upgrade or whatever, and you're kind of done with that part of the standard. But on CoreOS, it's kind of weird, right? Is an auto-update okay? And I think for most people trying to get through compliance, it's going to be one of those questions of which specific standard you're going through and how the auditor thinks about it. In our case, we kind of said, hey, look, you like antivirus auto-updates, right? And this is all signed, and we'll run it in our beta environment for a week before. Let's do it. Let's not turn it all off. But for a while, we actually were turning it all off. And so I apologize to all the CoreOS employees. Here's how you turn off auto updates. It's really pretty easy. You just tell it reboot strategy off, and then, well, so actually, to be fair, this doesn't actually turn off auto updates. It just doesn't reboot after it downloaded and installed it. But that's probably what you want. Like, no, don't tell the auditors that it's still downloading stuff and installing stuff. Just say this is good enough. And, you know, I don't know. It's not fun. But I think this will get better, hopefully, as standards kind of get used to SASs and things auto-upgrading and everything else. It's just the standards are running behind. One other note, you can use Core Update by CoreOS. They have a service for this, so you can manage your beta cluster or dev cluster separately from prod and kind of decide when they get different versions of CoreOS. So for some people, that's probably the easiest way to go. And that's all I have on the broad topic of all compliance things. My slides are online with all the links too. Does anyone have questions?
You talked quite a bit about PCI. Have you actually been through PCI audit?
Not for Scale of T yet, although we are probably angling to do service provider sooner than forever from now, but not yet. Some of our customers have been through PCI where they're using our product, and that's where they send us all these questionnaires. And so far, we've been able to convince them that we didn't have to be a PCI service provider to use our product. But I think for us as a product, we want to just say, oh yeah, of course we're PCI service provider, but you know, more things to do.
Are there other kind of compliance regimes for a SaaS business like yours that are relevant?
PCI is the easiest to just talk about. I mean, FedRAMP has a ton of stuff if you're trying to get into more government organizations. HIPAA, I don't know how much you know about HIPAA. You know, it's vaguely complex, maybe is my simplification of it. And so they still want a lot of the same, you know, user IDs and logging and a lot of the same concepts. But yeah. Any other questions? Oh.
You mentioned that you're using Ansible for configuring the CoreOS. I'm using Ansible too, and as one of the advantages I knew that it doesn't require any engine. I'm just curious why I'm using the engine when it makes control to deploy it. We can use it with like a step. Why configuring real the agent?
So the question is like, why do we still have some agents, I guess? Yeah. So it's mostly that as part of some of these compliance things, like the antivirus agent is probably the silliest one. Ansible is not an antivirus software, right? Like it can help you deploy these things and do different things, but it's not gonna replace all possible agents. Or things like a backup agent that's backing up a snapshot every hour. There's things that just aren't, I guess, in scope of Ansible. But yeah, I mean, we use it for a lot of our normal tasks. You know, I'm not saying you have to have an agent for everything. Well, I mean, in contrast to like Chef or Puppet, I guess is kind of the question. Is Ansible in contrast to those, or? Mm-hmm.
Which doesn't have any agent. Like
yep.
Or whatever. So I'm using Ansible to fix the nodes. And it doesn't require the agent. So
right.
Do you have any advantage to having the agent inside for Ansible?
Oh, we don't use any agents from Ansible, I guess. We just use all remote SSH. Oh, so we're deploying just the Python runtime to all the machines so that Ansible then can gather facts and all the other things it does. But we're not deploying Ansible, the full thing. We're just deploying PyPy so that Ansible can run. Any other questions? Ed?
You mentioned some of the hurdles with Cloud.net.
Yeah.
Did you look into Ignition at all for that?
So Ignition is at 0.4, I believe. 5, okay. I mean, CoreOS unstable moves quickly. I I would say if I was starting from 0 today, I would probably try to use Ignition. But even like CoreOS stable, I think has like Ignition 0.2 or something. So if you're on stable, it's still probably a little early. But yeah, Ignition solves most of these problems. But you're still probably going to go with a very small Ignition config, right? Like all I would probably do is move our Bootstrap into Ignition, which would then mean you just one less thing running. But we're still trying to do a very small shim to get started, and then bootstrapping to Ansible.
Just a second, we use dynamic URLs for the Ignition config and the cloud config. So
Yeah.
whenever you go Lifecycle Management develop scope, whenever the thing reboots, you can generate new
Okay.
cloud config or an Ignition config on the fly.
Huh. Yeah, so he mentioned that they basically generate a dynamic cloud config so that on reboot, you actually get the new cloud config. That makes a lot of sense, I think, in general. It solves some of the hurdles we hit. I think our challenge is also we use a lot of public clouds, and things like user data is not necessarily editable. But yeah, you could set it up to use a remote URL. Cool. Any other questions? Okay, thank you.